Computers are causal. Let's rename them causers. Scott Allman.
Thank you to Squad for allowing me to give this emerging topic. Why call them causers instead of computers? In the early days, computers were prized for their mathematics. They did a lot of computing. And I maintain that these days they don't. They spend a lot of time passing messages, responding to sockets, and so that the kind of bug reports that we file and the kind of tools that we need for designing tests have changed. And one way to take advantage of the changes is to try and look at the behavior of software from a causal perspective. So the picture that you're looking at on the screen is from a game that my children had, where there was a puzzle, and you used simple understanding of causality to solve it. So look at the bottom, you'll see a cannon. And if you fire the cannonball causes the boxing glove to push a tennis ball up and over a ramp. When the ball falls down the ramp, it causes the scissors to close, cutting a string, which causes the balloon to rise, which causes the cat to be scared, and you get the idea. And I think everybody understands that kind of causality, and there's no computation involved. So you'll understand my presentation a bit if I start with a high-level view. This is an emerging topic, and I look forward to feedback at the end, because what I'm saying, well, it may pan out and it may not. It may just emerge and that will be the end of it, but it's worth going over. So I'm going to start by talking about causality as a topic for software tester. Then I've got a few things to say about subjects that I don't think apply to software testing that are causality. Third, I'm going to go through insufficient, non-redundant, unnecessary but sufficient conditions as a way of explaining what we do in software testing. It's not my idea. It comes from this Australian named J.L. Mackey. And my wife suggested that I contact him, but he's been dead for about 20 years. So perhaps if you could help me do that. And then I want to talk about the next steps for this idea. So when you write a bug report and you want the bug to be reproduced, you put in it the sufficient conditions that if you do these things, you'll see the issue that had a surprising result. An even better bug report has the minimal, non-obvious, and necessary steps, because there's many different ways. It's called overdetermination to get to an effect. So that's something that an understanding of causation will make you a better bug report. I think it'll also help us when we design experiments. I already talked about how boundary value analysis and equivalence classes are good for mathematics, but not so good for causal stories. And what I'm really interested in is what would it look like to design tests based on their causality. When you read through the causal literature, if you want, you'll see lots of diagrams, causal diagrams, to show what kind of puzzles. So what I had in mind was something like a mind map, where instead of specifying the relationships, what you do is you specify the causal relationships between various events. So far, so good? Okay, so I've got to say a few things about the causality that we're not interested in. I've been talking about this for a few months with my colleagues, and I said I'm doing this talk on causality. And with one of the members of my team, and had found a bug that day. And I said, so what caused that bug, Steve? And he said, well, here's what happened. There was a problem in this one part of the code, but the solution was over in another part. So the developer just copied the first part of code over to the second, which is a bad idea. And then later on, someone came along and they fixed the bug in the first place, but they didn't fix it in the second. And since the developer had failed to refactor the code, according to this developer, the cause was because somebody copied code. And I don't think that's normally what people think of. If I put that in a bug report, I said, I found this bug in Christine's code, and it's because she copied things. That's not what they're looking for. So that's not what we're talking about. And Aristotle, if you studied his kind of causality, that would have been his formal cause. We're not going to talk about that. Second is there's a lot of causality talk about skepticism. You know, Hume was interested in if just things, one event follows another one in regularity. Is that good enough for causality? Well, day follows night, night follows day, day follows night. So does day cause night? Does night cause day? Do they cause each other? We're not going to get into that because that's not what software testers talk about. I don't want to say anything about trying to figure out the essential nature justification. Forget that. A lot in the literature is about simultaneous causation. Again, I don't think that applies, but it's worth going over. So there's this law called Boyle's law, which says that you can relate three factors about a gas. And there's a relationship between its volume, its pressure, and its temperature. So there's a lot in the literature about does temperature and pressure cause volume? Does volume and pressure cause temperature? I don't think we talk about causality that way in software testing. And I'll get to what we talk about here in just a moment. Statistical causation seems to be really big in quantum mechanics. I don't understand quantum mechanics, so I'm not going to go into that. Just a couple more things here. Alternative overdetermination shows up when you read about moral responsibility and determining legal causes for things. So there's all kinds of interesting stories. A despondent person decides to hire a gunman to kill them so that his family can collect on the insurance. And so this hapless lad is walking down the street. The gunman pulls up in the car to shoot him, rolls down the window, and at that exact moment, the guy has a heart attack. And so what killed him? Was it the heart attack or was it the gun? I don't think we're interested in that. But if you're trying to make the story as the insurance company or trying to answer the why question, why did this person die, it's important. I don't think we have to worry about those. There's other ones like there's a tramp staying in a barn and smoking a cigarette. Lightning comes through and hits the hay. It starts on fire. At the same moment, the tramp throws his cigarette in. Again, we laugh at those because that's not the way we worry about those. There's also this, a couple of bloopers that I want to talk about. When you file a bug report or design a test, there has to be the idea of a causal mechanism. It shows up a lot in the work that I do where we test wireless systems that are on isolated networks. And so if you file a bug report or you design a test where you don't take that into effect, you're not going to be taken very seriously. It used to be simple when there was no threading and there was single processes and no concurrent code that you could say, well, we'll just follow the execution of the instructions. And that's a good model to keep in mind, but it doesn't always work out that way. One thing that we do, but you have to be very careful about, is the difference between predisposed and triggering causes. So is the cause that you're talking about something that was just sitting there waiting to happen? Say in the Java world where I work, an uncaught exception, or an unserialized object, or is it in fact the event? And in your bug reports and in your designs, you need to keep those things in mind. So that's what I wanted to say about what we're not going to talk about. How am I doing for time? Oh my goodness, okay. So I think we understand how tester causality works. a single sequence of a computer events. There's always going to be more causes going on than you can identify and describe. Just assume that they're background and irrelevant. And you can express causality two ways. You can do it in the white box sense by saying, here's what happens in the code. Or you can abstract to a different model and say, based on the behavior of events that I can chunk together and make sense, we'll explain causalities that way. So imagine an example where you wanted to save a file and it didn't. You could say that the cause was that you picked the save option, and the effect was that it didn't, but it depends on background assumptions like the hard drive is not full, et cetera, et cetera. So you got to tell the whole story. Okay, so John Mackey, a while back, wrote a book called The Cement of the Universe. And the term is Hume's, and he says that's what you need to really understand what goes on. And he tells a story that a house catches on fire, and an investigation commences. It doesn't burn all the way down. It discovered that there were some flammable rags left in the attic, and there was a sprinkler system, but it was not turned on. So what are the factors that caused the fire? And the letters talk about what are the insufficient and non-redundant and unnecessary insufficient conditions. So it was sufficient that there be a fire, but it's unnecessary that it be caused by the rags. There could have been an electrical failure, there could have been an arson by somebody, et cetera, et cetera. The non-redundant, let's just leave that aside because that's just for technical philosophers. And the insufficient stuff is saying, well, it's not, the insufficient is the sprinkler system could have been turned on, the sprinkler system could have been left off. Here's a contrived code example in a language I made up. And it's going to arrive at a division by 0 at the end. Most bug reports would say, oh, the runtime error occurred because you divided the top number by the bottom and the bottom was 0. But to put it into my framework, here's what you go. That's the sufficient cause. It's not necessary that you have the value of bottom be 0 because there's this little variable in front called gate. And if gate isn't set, then it won't get there. Yes, please. Oh, dear. You are so right. My apologies. And to all the folks at home, and we won't be right back after this because there's another speaker coming up. Thank you. So here's the contrived code. And I was going to go through quickly those 4 conditions. So the one that most testers start with is what are the sufficient conditions? And that is that the runtime error occurred and you saw in the log that there was a division by 0. Number 2 is, well, that's not insufficient because it depends on 2 things that happened before it. How did the value of bottom get to be what it was? And what was the value of the gate? And so you want to put those things in your bug report and in your designs. Third is, if you know it, it's worthwhile mentioning the unnecessary. In this case, the value of the top, the variable that's being divided, really doesn't matter because when you divide something by 0, it's game over. But it would be helpful to say that, this is a simplified example, but to other people that might want to do some exploratory testing down the road, is to say you don't need to value this variable. And so those are the examples. So the next step would be to try and translate some more bugs and error ideas into this framework. If other folks know of articles that might apply to this, I'd love to hear about them. And I think that's it. Wait, one more. So I put up this slide because I have a garden and I'm a gardener. And people always say, wow, you do such a great job of growing your garden. No, I don't. I don't cause my garden to grow. I may plant the seeds and I may rototill the soil, but the causing is something entirely different. While I am here, my garden is growing, and I'm not causing it to grow.
Thank you very much, Scott. I do think you probably help your garden to grow, though.
You think I do help it?
I think you probably do.
Well, we need to talk.
And we're in open season. Any questions?
Okay, thank you very much.
If we want to keep talking about causality afterwards, feel free to grab Scott in the hallway. Thank you very much.
That was Scott Allman with Computers Are Causal. Let's rename them Causers.